Last lesson we started looking at differentiation from first principles. Okay, so that's the formula you need to know. Alright, this is the formula when a secant, so a line, straight line that cuts the curve at more than one place, becomes a tangent. Okay, so to achieve that, we need to first do a bit of manipulative work for that formula. Okay, once we work out the value of f dash of x, that'll give us the what?
Gradient.
Of?
Differentiation.
Yeah, what does the end result?
Straight line. It's the gradient of something.
Yeah, you on that track? Gradient, yes? Of what? The gradient of the? What have we been doing so far this topic?
Gradient of the... Was it turning point? No. Why?
Did you say something that I missed?
Not this part. Tangents?
Excellent. Alright, so the result of this formula gives you the equation of the gradient of the tangent at any point x of the curve. Alright? Equation, gradient, tangent. There's three things it provides in that order. There's your formula. So I've got a couple more to do from last lesson. Right, C. We now have f of x equals 2x squared plus 5x, take away 1. So the question will say differentiate by first principles. So when you see by first principles, you need to do this method, and I'll explain more about that as we go through this lesson. Right, so in our formula we already have f of x, so we're going to put all that with a bracket in place for that. But we need to also have f of x plus h. Alright, so that's probably the first thing I would suggest you do. I wouldn't suggest you put it all in the formula straight away. I suggest you get your f to x plus h in the next line and then put it all in the formula, okay? Because sometimes it involves simplifying and you'd rather get it done without worrying about the rest of the formula. Okay? Alright, so that means every time there's an x, I'm going to substitute in an x plus h. So it equals 2 x plus h, all squared, plus 5 outside of x plus h, take away 1. Okay, so that's why we do it on the side. We don't put it in the formula straight away because we have to do some tidying up. Alright, I'll do this one step by step. Some people seem to have issues about Friday afternoons and productively working, so I'll take you a bit more further into your work. Wow, that's one more than me.
Pardon?
That's one more than me. Probably have more bed some point this afternoon. Very good, Amanda. Okay, so we're expanding and then we need to simplify. Get it as simple form as you can.
So you should come up to the cafe at recess Friday.
Yeah? Oh, I will now.
And I can make you a coffee.
Very good.
Then you can have 3.
Well, that would depend. Am I in all of your good books at the moment? That would depend. Am I all in your good books at the moment? Or people just not really liking me at the moment?
Why would we not like you?
Hey?
Why would we not like you?
I don't know.
My N award is my fault.
So I'm thinking after some of your parents had some conversation with you over the last week or so,
No,
I'm thinking there might be a bit of tension in here. No?
I've actually, I don't know. I think it's just you. I think you think we don't like you.
It's okay, so we
I know.
this is us.
I'm just lightening the mood.
Well, now you've made
He's just trying to
Now I made it worse, have I?
Yeah, now you've made it worse.
Oh.
Now it actually
Bummer.
I'm joking. No, the N award, that's my fault.
Uh-huh.
Oi,
Oh, just on that, while we're on that topic, I'm not sending out any awards at the moment. Okay. So give you guys get a chance to get some work done first, okay? Now I've spoken to...
Most of our parents.
I'm going to speak to yours this afternoon.
Yeah.
I've tried contacting yours, spoken to yours too.
Wait,
Recently?
I've
Yep.
already spoken to her, so she knows.
Yep, but I'll be having a conversation with her, so.
The last Tuesday you tried contacting my parents again.
Hey?
Did you try contacting my parents
Yeah.
Months
Don't get very much success.
Did you try last night?
I tried about 4:45.
How did you know?
What time did she
My
finish?
mum was working evenings yesterday, but today she should finish about 4.
4. Right, thank you. Just keep tabs of where everyone's up to. Yeah, we can't... Well, I'm just rewriting everything again. Yeah. Hey, just make sure you get the right working there. Yep, we'll just write it again, just to make sure. You know, the really painful thing, you now got to put all that in your formula and then the next bit. Alright, so f dash of x, let's put it way over the side of your page. Right, we take the limit as h goes to 0 of f of x plus h, which is all that. So 2x squared plus 4xh plus 2h squared plus 5x plus 5h. Take away 1. Take away f of x. Now, because you've got more than one term, that needs to be in bracket, okay? Because you take away everything as part of that term. All over the locum h on the bottom. So the idea now is to simplify as far as you can, and because we can't substitute in 0 at the bottom, we need to be able to factorise the h out of everything, which we should be able to do for this formula to work, and then cancel it with the h on the bottom, okay? Right, so 2x squared, take away a positive 2x squared will give you 0x squared. Positive 5x, take away a positive 5x. Okay, so you've got 5x, take away 5x, which is 0. Negative 1, take away a negative 1, so it becomes a negative 1 plus 1. So they'll cancel, so that's what will happen most times. And everything else involving h's. Of 4xh plus 2h squared plus 5h all over h. So, that's what we're looking for. Everything on top has a factor of h, at least a factor of h in it. Alright, so limit as h goes to 0 of h outside of 4x plus 2h plus 5 all over h. Great, we can now cancel. Everyone following so far? Essentially chapter 2's work. Alright, so now that we have got this into simplest form, we can now substitute in the limit value into the equation, okay? Into the expression, sorry. So it becomes 4x plus 2 lots of 0 plus 5, which is 4x plus 5. Alright, so this gives you the equation of the gradient of the tangent at any point x on the parabola 2x squared plus 5x take away 1. So the point on the curve where x equals 1, what is the gradient of the tangent? Pardon?
Yeah.
At the point where x equals 1 on the curve, what is the gradient of the tangent?
It isn't 9.
Hey,
Isn't 9.
it is 9. Everyone see where that came from?
Yeah.
Speak up, I'm not asking you a trick question. Alright?
But we might get it right.
You'll probably say no.
I'm making an effort to listen today. Alright? X is 3, so the point where x equals 3 on the curve, what is the gradient of the tangent? Okay,
17.
thank you.
Making
Alright, so we've got a slope of 17. What about x equals negative 2?
Negative 3.
It's negative 3.
Negative 8 plus 5, negative 3.
Basically, when x equals
Just
1,
substitute what he's
you
saying.
substitute the 1
Oh, we're
into
actually
x.
doing something with that.
Yeah.
Okay.
I'm glad we're getting it. Alright. Alright, last one of this example set. F of x. Alright, nice simple one, 2x plus 1. Right, so the question will say differentiate from first principles. So you need to know that formula. You also need to first work out x plus h. Right, so we know how to do that. We'll cover more of that when we do functions and graphs. But just to get you going algebraically, this will do. So, f dash of x. So the dash tells us what's called the first derivative. Okay, and the derivative is referring to the gradient of that tangent. So we take the limit as h approaches 0 of, let's write this formula, f of x plus h, take away f of x, all over h. Now, until we take that limit, we need to still write this section here, the limit as h goes to 0. Okay, I know some teachers that will mark you incorrect if you don't write that.
Can you have
Alright.
any other variable instead of
Yep,
h?
any variable I want. So I can put limit as k approaches 0, and if I've got variables k, that's what I'll put in there. Yeah,
Can you have
absolutely.
Other than 0?
Okay.
Can you have anything other than 0?
Yep, you can have whatever number you want. Alright, we'll talk about that more in functions and graph, and look at more further significance in extension 1 and extension 2 for that concept for you. Alright. Alright. Limit of 2x squared plus 2h plus 1. Take away 2x plus 1. Away over h. Yes?
Where's the square come from?
Sorry, thank you. No square there. I think we had a quadratic. Limit as h approaches 0. The 2x, take away 2x, and then you have a positive 1, take away a positive 1. That's what you usually happen when this concept goes. Of 2h over h. Looking different. So that means just 2.
Oh,
What
This
does
isn't
this...
as hard as I thought it would be.
Hey?
This isn't as hard as I thought it would be.
Oh,
not
good.
yet.
Yeah,
Yeah.
true.
You have to wait till the end of the lesson to make some comments like that, Nicola. But I'm glad you say that now. Alright, so what does this tell you? What does this 2 tell you?
That's just 2.
What just 2?
The gradient x, y is 2 points.
The gradient of the tangent.
Is 2, yeah. Now, before we had variables of including x here, didn't we? This one doesn't. Alright, that means any point on that curve that we have there is always going to be 2. Why is that?
Because it's not it's a straight line.
It is a straight line, isn't it?
Yeah.
Okay, so it works. Anytime I put a tangent on that line, it's going to be the line itself, isn't it? Okay, so that's what I wanted you to discover, and well done. Alright, so that covers exercise 8.4.
What? Is it maybe that your texters that are making it so...
I think it's the rubber.
It's just some...
If I were to put that right there, it'd be very dirty, I reckon.
Use one of the other ones. Are they any better?
I feel like I've got to work harder to do that though.
There we go.
Oh, there we go.
It's still fine.
And if they Crayola rubber. Very ironic because you don't really rub off crayon, don't you? Do you even know what crayon is?
Yes.
Yeah.
Good. Alright, 8.4. Now, there was an 8.3. We're skipping that, alright, for now. We'll go back to that on functions and graphs. Alright, so we're skipping 8.3 for now. We'll get back to it when we do functions and graphs. Alright, short methods of differentiation. Okay, so this by first principles is you are doing differentiation. You are calculating things involving the gradient of the tangent by using the work on first principles. Okay, so fortunately, mathematics allows a quicker method as opposed to differentiating from first principles. Okay, let's work out the following. If f of x is equal to 3x, what is the gradient of the tangent at any point? 3. Alright, very good, Amanda. Now, f of x equals x squared. F dash of x is 2x.
I don't understand what's going on.
Well, X times
Yeah,
X
because
is
you're...
2.
Are we noticing anything so far? Right, f of x is 5x squared, take away 4x, f dash of x is 10x, take away 4.
Oh, you're timesing the power with the
Starts with C. Starts with C.
constant.
Nope. Co is correct. Hey. Don't go off on a tangent.
Oh, I just got that. Oh my goodness. so is it like x squared is 1 times 2? So 5 times 2 is 10? Is that it? Okay.
But not just that though.
And then you have to put in whatever's
A
behind
tangent
it.
doesn't cut through a circle.
Yes, it does.
Oh,
And then it
wait.
goes through a triangle.
Alright. Tell me a random equation involving powers. Go. Someone. This is your element. Go.
Wait, why is my element?
Because you're creative.
Lol.
And now I'm not creative.
Bad.
What?
Give me a polynomial.
Polynomial.
Yeah.
Oh, I forgot. No, I forgot those.
Something that looks like this
Yeah,
with integers powers. Positive integers.
How many of them do you want?
As many as you want.
Really? As many.
Well,
of
if you
them?
want to waste everyone's valuable learning time.
Oh, let's go. 7x to the power of 3
Yeah.
minus 3x squared plus 10 equals, no, not equals, plus,
21
I don't know.
negative 6
I'm
Stop.
going for- yeah, just
Alright,
stop it.
what's the answer then? So you understand.
21 squared, 21x squared, plus, take away 6x, yep, and then plus 10? Plus 10?
That's it.
Is that it?
Yeah.
Okay, great.
Alright, Michaela's got it. The rest of you. Michaela's got the pattern. She identified what's happening.
I said that.
Yeah? So, say it again.
Yeah.
Alright, you come up with one then. Josh, go.
Oh god. 2x
2x.
Power 3.
Yep.
Plus. Bloody.
How hard is it to put random numbers in front of the same letter?
3x squared. Take away x. Plus 5.
What's the answer then?
Is it 6x squared plus
Hang on. Yes?
x squared plus 6x and negative 1?
Yes. Right, do you got it?
Yeah.
Do you have it?
Yeah.
Do you have it? Yep.
Yeah.
Do you all identify what's going on?
Yeah.
Yes, very good.
No. Okay.
Go back to all of your first principles question. Look at the f of x, and what did you get as your answer? All of you. Look at your f of x from all your a, b, and c, and d from the differentiation by first principles.
Right.
What were your answers?
I actually did notice that when we were doing them. I was like, we're doing all this. Can't I just take that first number?
Why didn't you say anything yesterday?
I thought that's a really lazy way. There's got to be some reason we're doing all of this long equation.
Yep, there is.
I picked up on that. Oh my god.
Why didn't you say anything
I
yesterday?
thought that we were doing
Oh,
it for a reason.
that would have been your just amazing moment. Life-defining moment right there.
Now you're a failure. You stuffed up.
No, she said it yesterday, should have been told.
Did anyone... Okay. Fair enough. That's probably why you didn't say anything yesterday. Because you, yeah, I wasn't being very good encourager of you, eh? Right, did anyone else notice it yesterday, though? No? Okay,
Only because I was comparing it to the answer.
very good. Okay, so...
Bo noticed that it was green.
No, it was blue.
No, it was blue yesterday.
It was blue, not green.
Okay, so consider a straight line. The tangent of any point on that straight line is still the line itself. Okay, so d dx. That's notation means you're differentiating. Okay, some constant times x, just a straight line. Okay, is going to equal that constant number, isn't it? Can't believe how many books you've gone through in mathematics. Yeah.
Oh, speaking of, I found my chemistry book. It was in the library.
When was the last time you got it for study?
No, because I swear I left it in the classroom about 3 days ago.
So you need to develop more covalent bond with your book.
Yeah.
Consider a horizontal line. Okay, horizontal line. What's the gradient of the horizontal line? 0. Okay, so that means y equals k, will be that form. So what is the gradient of the tangent at any point on that line? So d of the constant k, it's not k actually. What's the gradient of the tangent? 0. Alright, so in other words, if you differentiate a constant number without any letters with it, it's going to be 0. Okay, so like here, you differentiate 5, okay, it goes to 0. Once you differentiate a constant number, it goes to 0. Differentiate 10, okay, it goes to 0. That's all the examples there. Alright. And in general, the derivative of an exponent, so d dx of k, some number out the front, n, sorry, all the way around, k to the power of n, okay, so it equals n, I'll put it alphabetically, k k n x. And what's happening with the powers? Why? How many? Yeah. Alright, so we're just saying we have more than one term of x. We had like 3x squared plus 5x take away 7, for example. So there's 3 terms involving x. So if you consider the 7 as a x to the power of 0, right, you can differentiate each term separately. Okay? So d dx of f of x plus d dx of g of x. Okay? And it keeps going. Plus or minus.
Hey, hold on.
In your course now? Okay, example A. So, differentiate the following. F of x is equal to x squared. So the notation when you differentiate is f dash of x. Tells me that you are differentiating f of x. And we differentiate x squared, we get what? 2x. Yep. So you bring the 2 down out the front, x, and take 1 off the power. Right? Yeah, because power is 1, we don't need to show it. Okay, so when there's x term, so 3x, when we differentiate the power of 1 of x, just set the coefficient at the front, and when we differentiate a constant number, right, it goes to 0.
Why is that?
Pardon?
Why does it go to 0?
Well, y equals k. So if y was 2, that's a horizontal line that cuts the y axis.
anywhere on the line.
No,
Okay.
this is when gradient's flat at 0.
Thank you.
That's right. C f of x is 2x squared plus 5x take away 1. Both.
That would be 4x plus 5.
Good. And D f of x is 2x plus 1. Kyle, f dash of x is? Now, yesterday we started looking at differentiation by first principles, and we finished those 2 examples today. Alright, so over 2 lessons we've done 4 examples on differentiation by first principles. In the last 3 minutes, you've done the same 4 questions.
Am I? Oh, wait.
Oh, yeah. Oh, my goodness.
So is anyone now hating differentiation by first principles?
Just you.
Because
Why do we have to learn a long way when there's this?
Well, you gotta.
Because you appreciate the longer methods. The examination can say differentiate by first principles. That means yes, you have to do it by first principles.
You gotta
And just
expand.
a short way to make sure you got the right answer.
Exactly.
Okay.
Alright, thank you very much.
With a little emoji with it.
When you are differentiating by first principle, right, you'll be able to tell me what the answer is straight away, wouldn't you? Right? So when you're working through the question, you know what you're expecting at the end.
You do.
Alright? That's the other reason too, yes. Plus, I'll find the long...
Lazy is so much better. If you get the same answer, why have to go through the hard way?
Okay.
There's an easy
Alright,
way.
the formal answer is, Amanda, is because your syllabus requires you to be able to do it by first principle.
Somebody needs to change it.
Right in the syllabus.
You gotta take it to
It's like,
all
it's
the
like
studies.
girls, and it takes you so long to say for a horse. You spend 20 minutes walking across the map, and then you get a horse, and it's so much better and you appreciate it. Until your horse.
You ride your horse.
That's a good analogy. Actually, I like that.
It's a very good analogy. I spent so long complaining on that game that I didn't have a horse, so they all bought me one.
When you spend like 4 hours.
How could you appreciate this method here, Amanda, if I didn't show you the long and tedious way to do it? And there are HSC examinations where it does ask you to differentiate by first principle.
Let's not even kick a ball. Let's not even kick a ball. I should do that for you.
Last lesson we started looking at differentiation from first principle. Okay, so
Let's not even kick a ball. I should do that for you.
last lesson we started looking at different.
Let's not even kick a ball. I should do that for you.
Yeah. Fantastic.
You know the good thing about primary school is the teachers would hit you with something hard and then go, now let's go outside and kick a ball,
No, that wasn't at our school. Our school was shit.
You guys had crappy primary schools.
What school did you go to?
The only thing I got to buy from a teacher at my school was my year 4 teacher used to throw my book at me.
You guys had really bad primary schools.
What you were talking about, I was like, beat as a kid.
No, hard
Me?
work.
So you just throw some hardest.
What?
Like hard work. She thought that they meant that.
Oh.
For
Right.
Some hardest, some hardest.
No, and then
I'm
we
not
got...
probably
no
didn't.
clue.
She officially lost it, so.
We go, and then we go outside.
I think it's going to take about 15 minutes to reel it back in.
My
Our teacher just yelled at us and told us we're going out for sport.
That's really... You guys had crappy primary schools.
We were the ones getting beaten.
I would have preferred to go to that school.
And I went to a public school, so...
So
What
like,
school are you going to?
Castle Hill.
Fair
And
enough.
Kings Langley.
There's a lot of Asian people there.
Oh, yes.
I was
They-
about to
the
say.
ATARs that are like...
over 9,000.
You personally feel like you were from another country, wouldn't you?
No, not really. I used to play...
Castle
soccer-
Hill, surely.
Once
I used to play
he was around.
street soccer with them at lunch on the basketball court.
Right.
And then when they got up a year, they were seniors, so they were allowed in the NPC, which is... And then so we played on a proper court. Like, kick a ball. Ball. Outside and kick a ball. Outside and kick a ball. Outside and kick a ball.
Last lesson, we started looking at differentiation from first principle. Last lesson, we started looking at differentiation from first principle. Okay, so that's the last lesson. We started looking at differentiation from first principle. Okay.
You check.
Yeah. He didn't send me to go see Miss Pinkerton about the decision.
Now what do I do with it?
Take it to Solomon.
Alright.
Like the easiest thing in basically.